Okay, now move on to the next topic for intermediate code generation is what is three address code generation. You already learned what is three address code generation. The three address code generation is a type of instruction. It can have three operands or two operands with it can have three operands or two operands. The three operands with two operators can have either it can x, y, z or three operands. In between these three operands, it can have two operator. For example, x is equal to y plus z. Or sometimes you can also have x is equal to y. X is equal to y is an example for the two operands with one operator for the three address code, and x is equal to y plus z is in three operands with two operators is also one of the examples of two address code generation. And operand could be, these are the different types of operand. The operand can be literal, or operand can be variable, and operand can be temporary variable. Then, what is an example for there are different form of three address code can also generated. For example, x is equal to y operator z, or x is equal to OP and z, because unary operator can also use, or x plus y star z. And you can also represent T naught is a temporary variable. T naught is equal to y star z, and T1 is equal to x plus T naught. Like that you can represent the three address code generation. And what are the types of three address code statement? There are different types of three address, but till now we studied only one type is x is equal to y plus z. But there are different types of three address code statement. Wherever you want to generate the code generator, then you can make an intermediate representation as a three address code. Depending upon the different way of statement you can generate for your own assignment statement. Okay, for example, you can also write for the assignment statement. The assignment statement is of the form. If you want to write assignment statement in the form of three address code, you can write it x is equal to y operator z. What is an OP? OP is a binary arithmetic or logical operation. And the second, if you want to write assignment operation in the form also, x is equal to OP of y. OP is an unary operation such as unary minus, logical negative, shift or conversion operation. Or you can have a copy statement. The copy statement can be written as x is equal to y, where value of y is assigned to x. Then unconditional jump of form. Then go to L, which goes to a address. The three address statement labeled with L. Then if you want to write there is no condition, but you should be jump to the label, then you can represent as go to L. The go to L is also one of the three address code statement. You don't think only the three variable, then these are the different form of writing the intermediate code representation. Now, if you want to write conditional jump of the form, how to write conditional jump? Then the conditional jump, as name indicates, there is a condition. See, if x relational operator, what is relational operator? The relational operator can be greater than, less than, equal to, less than or equal to, greater than or equal to, or not equal. It can be any different types of relational operator between y. If x relation operator y go to let, if the condition is true, then go to yes. This is also one of the type of representing with intermediate representation. With relation operator as a relational operator and go to executed if x reload y is true. Next, how can I represent for the parameter? That is a function calling for the parameter passing or function definition. For that, parameter operation of the form param a, then a is a parameter of a function. Then how to call a function? It should be used call p comma n. Call function p with n parameter. That parameter a1 comma a2 comma dash dash a1, that can be represented as a call p comma n. If you want to return anything from the function, that can be used as a return y. Return value y from the function, and it is an optional depending upon your program. You can also write this as a return function. There is a parameter a, parameter b, parameter c. This is the number of parameter. Then how can I call a function? Call p comma 3, because I have a 3 parameter a, b, c, for that n should be 3. And the next form is then you are also can used for representing as indexed assignment of the form. Indexed assignment of the form, then x is equal to y of I. Then what is the meaning? X is equal to y of I. the content of y of I should be copied onto x. There are also only the three things. The x, y, I. There are three operands only should be there. Set x to ith memory location of y, and x of I is equal to y, and the y value should be copied onto the location of x of y. That means the set ith memory location of x to y. Note that the limit of three addresses x, y, I means we have only three operands only. One is x, one is y, one is I. And this is not possible. See, x of I is equal to y of j. Because as the name indicates, we are writing a three address code, then it will not take more than that address. Then this type of representation is can't write. X of y is equal to y of j because the four addresses. Then how to write for the pointer? The next one, the pointer, the addresses and pointer assignment of the form. You can also write x of is equal to ampersand y. What is the meaning of that? The x set to the address of y. Then x is equal to star y. Then x set to the content pointed by the y. Then star x is equal to y. The content of x set to the value of y. Okay, these are the variety of representation for the three address code. If it is asked for a different form, then address can be represented as a literal or name, or it can be any temporary variable. And after that, these are the different forms of representation. You can underline it. And the same thing I had also shown it in that notes. Then I written the same thing. You can also write for this three address code at most operator is one right hand side of the instruction. That is, there is no built-up arithmetic expression is permitted. If it is source language expression like x plus y star z, that can also translate into instruction t1 is equal to y star z and t2 is equal to x plus t1. What is t1, t2? T1, T2 are the compiler generated temporary names. That's another temporary name. And for example, if you do this expression a plus a star b minus c plus b minus c star, then this in the exam you get a statement convert into three address code. You can convert it to three address code, and correspondingly you can ask the question to write it DAG. The last class you learn how to write it DAG for that one. Identify the common sub expression for that. According to that, you construct a DAG for this one. After constructing the DAG, then you should write a three address. Again, there is no interrelation between. You can go with any one as the first one. Okay. See, first you should be evaluated with the parenthesis expression. The parenthesis expression is b minus c. I am stored into t1. Again, after getting the t1, I should be multiplying a. That is the previous answer with a star t1, and that should be added with another plus a plus t2. Then I have to move for the second one. B minus C is already calculated. You take the B minus T1 into D. B minus C into D I have to do. The finally, what are the values computed from T3 and T4 that should be added. T5 is equal to T3 plus T4. Like that, you have to write three address code for any of the expression. Okay, now is B minus C because the parentheses are executed. The left is star. You write the parent of minus is star. After that, what is an operand is a. That a have a plus, that plus is visited to a. And the left part of the portion is O. Then you want to the right part, b minus is common. You already visited b minus c. Then you should write star and you have to write t. And I told there are different types of representation address and instruction. It can be name, it can be constant, or it can be temporary variable. And there are different forms of three address code, assignment instruction, and x is equal to OP, then is for copy instruction, x is equal to y, unconditional instruction, conditional instruction, relational instruction, procedural call, function, and you can use indexed instruction and pointer instruction. Okay, these are the different forms of representing three address code instruction. Okay, let me take for example, assume this is a problem. Consider the statement do I is equal to I plus 1 while a of I is less than b. For this is one statement. How to convert this conditional statement into three address code representation? Okay, write two possible translation of a statement. That means there are different possible can also write. But now I am showing how to convert this the statement into three address code generation. Okay, now because of the new function, I have to use the label for the conditional for that one. Okay, first I have to do, I'm taking the label L. See, because I have to do the iteration process, I is equal to I plus 1 till the less than b. Then what are the first calculation? First, I want to compute what is I plus 1. Then temporary variable t1 is equal to I plus 1. After got I plus 1, where to be stored? That I plus 1 we stored it into the corresponding variable I. Then the t1 will be stored into I. Then I have to go for the next one. While a of I is less than b, I have to compute a of I. A of I is an array. That array is contained for one location. Each one location in the array it will take 1 byte. For 1 byte is equal to 8 bits. For that, I have to take the location of A0. I require 1 byte complete. For that purpose, every byte that location should be added that can be represented in intermediate code representation is I is equal to T2 is equal to I star 8. Then I star 8 is only for taking for 1 byte of memory for A of 0. That will be stored in T2. The next step is A of T2. What is A of T2? Is complete the memory location. T3 is equal to A of T2. This is the way of representing for array value. Then finally, I want to apply a condition. If T3 is less than V, then go to L. And what is the condition I'm writing? If T3 is the condition. T3 is less than V. V is a normal variable. Okay, T3 is less than V, then go to symbolic label L. Okay, instead of giving the label, you can also give the position number for the each statement. Okay, that's each statement I am giving 100. The first one is stored in the discrete for 100. The 100 T1 is equal to I plus 1. 101 I is equal to T1. The same thing 102 I0 T3 and T4. Okay, this is another way. One can be used by using a number or by using a label. Where to be go? So go to I don't want to use the label. I have to go to the number. Which number should we go to? The number is 100. The 100 is incrementing the I value. That's the should be right this condition. Because I'm not used to do while just I'm representing that will be instance of if condition, but both are doing the same task here. Adding and doing. Okay, this is the way of representing. I explained whatever I did. Okay, now I have move on to the next topic. That instead of the address code that can also represent in different forms. The description of the address code instruction specifies the components of each type of instruction, but it does not specify the representation of these instructions in the data structure. That means in compiler, the instruction can be implemented as an object or as a record with the field of operators and operands, and such the representation are called as quadruples, triples, and indirect triples. That means this is also one of the form of representing your three address code generation. See called the three address code representation. The data structure for representation for three address code can be an object or can be in records with the field for operators and operands. And representation can include quadruples, triples, and indirect triples. Then how to represent quadruples? In the exam I always give represent the given this expression in terms of quadruples. Then what is the quadruples? As the word of quad, quad have a four. The four field should be there. But remember, in the quadruple representation, there are four fields for each instruction. What is the field? One is an operator field. Next is argument 1, argument 2, result. How many fields? 1, 2, 3, 4. For the binary operator have the obvious representation. When operator contains any of operator. Unary operator don't use argument 2. That means if I use unary operator minus a, then operator contain minus, the argument contain a only, but argument 2 is does not use. Then operator can be param, does not use either argument 2 or result. That means that function calling the parameter we are not using it. This is not like an operator. That type of we are not representing quadruples. And jumps put the target label into result. If you are using jumps, then what are the value you are operating in that label, that will be taken as a result value. Okay, now we can take an example. In the example, you will get if the given expression A is equal to B star minus C plus B star minus C. This is an example. How can you represent three address code and corresponding in the quadruple? Okay, let me see. First, you should be converted to three address code. I told the unary minus is the highest series compared to arithmetic operator. Then T1 is equal to minus C, T2 is equal to B star T1, T3 is equal to minus C, T4 is equal to B star T3, T5. Here you have to take the duplication also. And T5 is equal to T2 plus T4, A is equal to T4. This is as per the expression I wrote the three address code generation. Okay, you can skip T3, you can directly take on that one answer, or else you can write it. The next step, how to minimize your code, you can skip this T3. Okay, now take operator, argument 1, argument 2, result. Okay, these are the fields I have to write for array representation, and this is the index value 0, 1, 2, 3. Okay, what the first line? The first line is T1 is equal to minus C. T1 is equal to minus C. What is an operator? Operator is minus. What is the first argument? Argument is C. Do you have any second argument? No, you leave empty. What is the result? The result is stored in T1. Because of that, I am writing result is T1. I want to represent it. Go to the second one. T2 is equal to B star T1. What is the T2 is equal to B star T1? Then operator is star and first operand is B. The second operand is T1. The result is T2. I am representing like that only. Third one, T3 is equal to minus C. Then minus C and T3. You can skip also, no problem. Then B star T3 star B. T3 is the second operand, T4 is a result. And T5 is equal to T2 plus T4. And plus is an operator, T2 is the first argument, T4 is the second argument, then result is T5. And finally, I have two operands, A is equal to T5, operator is equal to first operand is T5, there is no second argument, right? In this type of representation is called quadruples. They have a lab program 5. The lab program 5 is also given expression is given, then but the question only will convert into three address code. So this is the three address code representing I'm storing in array. Because of that, you are creating your input file in like this format, and you are accessing from that input file the argument 1, argument 2, and the result to have to generate your code generation. The program 5 says the three address code will be given as input. Then you have to write a file for the code generator in terms of assembly level language. Because of that, I am passing your input in the form of this format. Okay, now the next type. The next type is triples. What's a triple? The triple is nothing but only three fields. Instead of storing an array, what is that? Instead of storing the result here one more column, I don't want to store the result in one column. Just I'm directly take this index value. If you want index, for example, star B T1. See, you are storing one more variable T1. The T1 is also same thing, and array index of 0 is also same thing. For that, I am removing to the last column result. I am taking the index value of this one. The index value of T1 is what? The index value of T1 is 0. It should be written in the parenthesis 0. If you want T3, then index value of T3 is what? 0, 2. Like that, that is called triples. Then the triple has only the three fields for each instruction: OP, argument 1, and argument 2. There is no result. The result of an operation x o p y is referred to be by its position. That means x o p y will become stored in the position value in the array index. Then you take that index value for your computation. The triples are equivalent to the signature of nodes in a DAG or syntax tree. Then triples and dog are equivalent representation only for the expression. They are not equivalent to the control flow. Then control flow is also another form of representation. It can have if, while, for, all those will become under control flow expression. Okay, ternary operations like x of y is equal to y requires two entries in the triple structure, and we record two entries. One of x is I and another for y. And similarly for x is equal to y, I. Moving around instruction during optimization is a problem. If you are using this one, then you have the next phase optimization will be very difficult to identify how to write your code. Okay, next, how to represent the same thing. The same problem item A is equal to B star minus C plus B star minus C. See, this is for how to write a syntax tree. The last problem, you know how to write for the DAG. Okay, now I for the syntax tree. I told the syntax tree, or you have to write both common sub-expression twice. How many times that number of times you have to represent it. If C minus star D and C minus star D plus equal. But that these two terms will be eliminated and only one term will be fitting. That's the syntax representation. After the triples, you have to use the same three address code generation. The three address code generation can only we use it in here. The first one is T1 is equal to B minus C. For that minus C have representing. Next one is T2 is equal to this representation T1 star B, because star B minus C, the minus C computation value is 0. Then I am representing the array index value is 0. Again I computing minus C star B. I have to get the value of minus C in the location 2 and represent parenthesis 2. Next is plus. Then I need for B star minus C. For that one I take 1 and 3. Finally I have to write the answer A is equal to that value. That value will be stored in the location 4 is equal to the argument 1 is A. Where the value should be stored? The value should be referring as a 4. That means A is equal to that result is what? The result is 4 only. That means instead of writing the result in a separate column, we are avoiding that one. We are showing that position of that result. And the last one is indirect triples. It is same as a triples. Then it's like giving a pointer to your array. Somewhere you are storing the answer. That answer will be referring indirectly. The triples is giving directly, but if the indirect, you know in the assembler, what is the indirectly? Then instead of giving the direct address of that one, you will indirectly represent the star. You have to go to that address will get it the content of those variables. That means I am giving a pointer to the triples table. I am accessing with those index array. If you are storing any somewhere in the array, that array will be pointed to your triples table. These consisting of listing a pointer to the triples. You have a triples already there, just give a pointer to triples rather than listing of triples themselves. Hence, instead of giving triples as well, you just giving pointer to triples. An optimizing compiler can move an instruction by reordering the instruction list without affecting the triples themselves. If you write also, it will not affecting for your next phase is code optimization. It will reorder what you rating that triples the same thing you will extracting. That is the indirect triple. How to represent? See your same table, then OP argument 1, argument 2. But this table I am referring in one more index array. Okay, this is the random number 35. That is in the array location. There is a 35th location will be pointing to 0. The 0 is nothing but 0 will be referring to the first location of the triples. Then 1, the 1 will be pointed to the first position of this table. Okay, like that, I'm giving a pointer to the triples table. We call as an indirect triples. That's a representation. Okay, this is the exam for any expression will be given, but it should be converted to quadruples, triples, and indirect triples. These are the some example I wrote it. Okay, this is for indirect representation. The same thing I written for the triples. The triples can also write representation, and for indirect, I am giving pointer to that topic. Okay, now it's completes for your intermediate code generation. We take an example. Translate an arithmetic expression a plus minus b plus c into syntax tree, quadruples, triples, and indirect. How to write syntax tree? You write it. Which one should be evaluated first? B plus c evaluated first. You write b plus c. What the next one is? Minus. That minus will be get plus and a. For this example, syntax is also same and we should write for DAG is also same because all are independent. There is no common between any of that. Then the syntax tree, if you construct DAG also, you will get the same thing. Then how to write tree address code, which is you have evaluated first B plus C. T1 is equal to B plus C and T2 is equal to minus T1. T3 is equal to A plus T2. Okay, now I get tree address. Because why you require? Because I want to represent these in quadruples. Now I am moving to the table is quadruple. The quadruple I told 3. 1, 2, 3, 4. For the first line, E1 is equal to B plus C. Then write plus argument is B, second argument C, where the result is E1. Second one, minus E1. There is no second argument. The result is T2. Next, equal first argument A, second argument is T2. The final is T3. Okay, this is the way of representing quadruples. Now I am moving on to the triples. How to write triples? Instead of writing the last column, you write plus C and no need to write the last column. Next, minus. Then what is the value of this? You already computed plus BC index 0. You write index 0. Next, equal A and what the value should be? The value should be stored in index 1. You represent index 1. If not required, the result. The next is indirect triples. You write the same triples. You referring to one array that you have to write any random number. Instead of always 35, 37, you can write any number. The pointer value, the 0, where the location is pointed to the first value, 1 second value, and this is the value. The value will be pointed to indirect triples. Okay, these are some examples. Okay, now I complete intermediate code generation. In this chapter, we have only two topics. One is how to write DAG and what are all the construction function to be used to construct your DAG, directed acyclic graph, and using SDD. This is the one concept. The common question is constructed DAG. The second common question is how to write tree address code by using quadruples, triples, and indirect example. Okay, these are the some of the only two topic in this also the intermediate code generation. So let for the one is a complex example I show it. If in case if you ask, you can write it. Okay, for example, how to write a syntax tree for this if statement. For example, if x is less than y and x is equal to 5 star y plus 5 star y by 3, else y is equal to 5, x is equal to y plus 1. If in case construct syntax tree or DAG for that given expression conditional. Do not ask, but if in case ask how to write. For example, this is what statement type. I told you can construct a DAG for the expression or statement. The statement can be any conditional loop, if, while, loop, for all those things. Okay, now I take it only for the if condition statement. This is a starter statement. The statement can be if statement or if the condition is true, it comes to here, or the next statement. If it is not, if it is the if condition is true, you go to this one, or else y is equal to 5. But after that, what you should go for the remaining statement. The remaining statement I am taking is the assignment statement. If condition or the normal statement. Then what is the if condition? If condition I have it these two, x is less than y. How to write? Then s less than is an operator. Then assignment. What is an assignment? Assignment can be these two operators. If it is condition is true, then it's go to the true statement, or if condition is false, it's go to the this statement assignment. That and if statement condition is true, go to assignment, or else go to this assignment statement. Then what is that condition? This less than is there is an operator between what? X and y. I wrote x and y. X is less than y. Yes, this is an operator. Then come to assignment. What is an assignment? You have x is equal to 5 star y plus 5 star y by 3. Now I have to write these statement into law of assignment statement. Okay, then how to write? Now how to take that x is an equal statement. So x say equals. First you go for the depth. 5 star y you are calculated. What is it? Which one be evaluated first? 5 star y. 5 star y I have evaluated first part. After 5 star y, next again I have to construct 5 star y for one more. 5 star y I computed. 5 star y will be divided by 3. Now right hand side is over, left hand side is over. Between these two I have a plus. That plus will be assignment is equal to x. X is equal to, I am writing this one. If in case if it is DAG, what to do? 5 star y will not come 2 times, only come only 1 time. That's a common sub expression. You have to try how to write for the DAG for this expression. Why I am showing for syntax tree. If you write syntax tree, it can easily construct your DAG. Okay, now what is an assignment statement for this? Else y is equal to 5. Then y assignment is nothing but equal. Then the value is 5. Okay, this is for if statement. If condition is true, then this will be assigned. Otherwise, this will be second part. Else will be. Then what is the remaining? For x is equal to x plus y. X is already there. X, y plus. Then is equal to. They almost 99.9% will not get these type of tough problems in exam. Always you will get an expression. But you should learn how can we represent this type of problem. Okay, and how to write for the DAG, directed acyclic graph for this one. Then directed acyclic, the same thing I took it, because no need to take too many times x and y. It's already there x and y. You should be give the link between the x and y wherever I'm calling. So assignment x and y. Give this link to x and y also. I told 5 star y already computed. 5 should be right, and wherever y, that line will be given. If you see here, it will get difficult. You should be write your own format and only can get it. Okay, now it completes our intermediate code generation. Thank you.